In this problem, we'll be finding the inverse of the displayed matrix, matrix A. We can only find the inverse of a matrix if it is square, meaning it has the same number of rows and columns, and the determinant is not 0. To start off, let's recall what the inverse means when dealing with normal numbers. The inverse of 9 is equal to 1 over 9. The inverse of 9 times 9 equals 1, and vice versa. The same can be said about multiplying the matrix times the inverse of the matrix, except for it is now equal to the identity matrix, which is a diagonal of 1s as displayed. Finding the inverse of a matrix and multiplying by another matrix allows us to divide matrices essentially. So the way we get to the inverse is by augmenting the matrix with the identity matrix. Our goal then is to make the original matrix into the identity matrix, and along the way complete all operations to both the original matrix and the augmented matrix. I am making the assumption that you know how to row reduce. If not, there will be this video which will be linked in the comments and descriptions for a review. The first step for finding the inverse of this matrix is we need to multiply row 2 by 1/4 to get a 1 in the second row, second column. We do this operation to both the original matrix and the identity matrix we augmented it with. Then we need to get rid of the 1 at the first row, second column, so we can subtract row 1 minus row 2. Now to get a 1 in the first row, first column, we need to multiply the first row by 1/3. This leaves us with the identity matrix where the original matrix was, and the inverse of the matrix A where the identity matrix once was. To check our work, we can multiply matrix A times the inverse of matrix A we found. It should equal the identity matrix. I would recommend, if you're completing a problem like this, using Google to find an online matrix calculator to check your work. That concludes this video. Hope to have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.